Okay, so here we have the MOSFET module. I'm going to show you the modifications I'm going to make to this part in order to make it function a bit better, and show you some concerns that I have on its design. So first of all, you can see that all of these terminal blocks here have only got solder on one side of them, and next to no solder on here. They do have it on the back, but I think while I'm here, I've got the soldering irons hot. I'll just reflow some solder in those areas. The next thing I'm going to do is beef up this track here. I'm going to put some copper filament along there and reflow the solder along there as well, and on this side too. This just really over engineer it and make sure that it's going to have full current carrying capacity. Obviously reflow these terminals too. Now I want to show you a part of the design here that I think is really worrying. Let me know in the comments if you think I'm not right here, but have a look here. You can see they've designed this with a nice milled hole in there, so you have an air gap between the positive and the negative, right? So nice and safe. But if you look in this corner right here, I'll see if I can focus in, get some light in there. Now between that corner there and that corner there is positive here and negative here. I've measured that and that is just under 1 millimeter. Why did they go to all the effort of milling a big air gap here, and they've just left this nice little area where potentially it could arc across? And you can see it on the back, the same as well, even better. That's probably about 1 millimeter or just under. So I am going to take a Dremel and cut the air gap in here. There's no PCBs on the front or the back, so I'm safe, I'm pretty sure, in doing so, just to help create a bit more safety there. And last but not least, this is the diode that needs an Inrush Current resistor applied in series with it, and I will show you how I'll do that shortly. And here we have the display module. You can see that it's model number CA20-2k. It's also very similar to the, I believe it's a CA20-2k. Virtually the same design, just a different number. Now over the back we have, of course, a little group of resistors, and you can see R4 down here in the corner. R4 is the one that we need to replace with around about 500 kilo ohms resistor. Now I don't have any SMD resistors, so I'm just going to use the inline ones. And it's going to be a bit fiddly, but I'm sure we'll be able to get it done. So let's get to it. So here I have some copper wire that I've just stripped off a piece of electrical wire that I had laying around. And I just stripped the outer off, cut it to length, and I'm just going to solder it now to tin it up. I'd like to take this time to acknowledge the work of YouTuber Luca. He's the one who has tested and worked out the improvement mods to this type of spot welder. I'll link to his channel below if you want to see the long in-depth analysis and reason for the mods to the Inrush resistor and R4 resistor. I'll be demonstrating these as well as some ideas of my own in this video. I didn't have a high power soldering iron at this time, so I had to use what I had, which are these two 30-watt ones. Not ideal, but it worked okay. An 80-watt iron would be ideal, and I did purchase one for the connectors later on. You can see I've reflowed those ones, they worked alright, and I used a 2-iron technique because you just need to dump as much heat as you can in there as possible. My single fine tip just wasn't enough to put enough heat in there. It's not a great job that I've done here, but I'll show you what I've done to try and get this copper wire here soldered in. I found that the normal solder was not working because it's got a higher melting temperature. So what I did was I used some of this solder paste, which has a lower melting temperature, and I've put that on the side as well. So I'm going to go ahead and solder this bit right in here. Just spin that around so it's a bit easier to see. So yeah, I'll solder that in there, and hopefully that solder paste will help as well. It's coming up pretty good. So just clean that up with some isopropyl alcohol. Oh, I'm happy with that. One thing I will mention, when you do any soldering around this area here, the gate leg of each one of these MOSFETs is this little tiny terminal here on each corner, and that comes through from these little traces here on this side. You can see they go through to the other side through these vias. So when you're doing soldering here, you have to be very careful not to bridge that gap like I initially did, and I had to just touch them up with the soldering iron, and I tested each one of them with a meter to make sure it wasn't shorted out, and they weren't, so I'm safe. And next we're going to put in the Inrush Current resistor in line in series with this diode, which links our power to this capacitor here. The reason why we've got to put this Inrush Current resistor in is because the amount of current that this capacitor takes when it charges up, is greater than this little diode can handle, and often they blow up. So by putting a 20 to 50 ohm resistor in series with it, it just protects it and just slows down that rush of current so that it doesn't blow up. So here I have a 22 ohm resistor, which I'm going to solder in now. I'm just going to remove that diode. Okay, so what I've done is I've just rotated this diode 180 degrees. See the stripe on it there still, just. And I'm going to solder it on. to that pad there. So what you'll see is this diode, instead of the power going straight through here, is now coming through the trace to this pad, and then it will be in a zigzag pattern back to this pad here. So electrically still going through that path to the capacitor, but it's just going to do a zigzag instead of flying straight through. Alright, so now I'm going to put my resistor in. There we go, Inrush Current resistor done. Okay, next we have to modify resistor 4 on the display module. So I'll remove that SMD resistor now. This one currently has 1000 ohms on it, and it's too large, it needs to be half that. Okay, here's our resistor, a 1/4 watt resistor. As you can see, it's pretty big, so it can't really sit directly on top. We'll have to put it slightly to the side and then bend the leads to suit. As Luca explains in his videos, the purpose of changing resistor R4 for a lower value is to improve the saturation levels of the MOSFETs when they are turned on. Some of these models blow MOSFETs because of this insufficient saturation, and these are a real pain to replace. It's far easier to change this resistor before you start using it. That'll do. So now that we've done those modifications, we can reassemble our spot welder unit. We can push the capacitor down. And screw the front and back on. I also decided it would be a good idea to protect the spot welder with a 3D printed case. So I spent an hour or so designing in Fusion 360 and a few hours printing with PLA filament, and now have a nice tidy box with a lid. I'll leave a link for this STL below if you wish to download it. I purchased these XT90 connectors from AliExpress for my battery leads. I'm sorry I didn't get any video of soldering these to the leads, but they're pretty straightforward as long as you have a decent soldering iron. As I said, I went out and bought an 80 watt iron to do these, which worked like a charm. You're probably wondering why I've brought you out here to my water tank. I just want to use it to illustrate a point about using correct battery and cables to power your spot welder. Now you can see here at the moment I've got a hose hooked up to it. It's a long hose, it's a skinny hose, and this is just a gravity fed, but it'll illustrate the point. When I turn on the hose, you can see it runs out at a certain rate. When I switch it off, it takes a while to respond, it's slow. I switch it on again, you see there's like maybe half a second before it gets up to full flow. It's because of the resistance of the hose. Now it's the same thing with electrical cables too. They all have resistance, and it takes time for the electricity to flow. Now I'm going to effectively shorten the cable by unplugging the hose. See, less resistance, instant results, more water pressure. Now what happens if we switch to a thicker cable? Now here I've taken the fitting off, and we've got, I think it's about 1.25 inches, 1.5 inches opening at the end of the pipe. Now when I turn it on, you'll see now we can get a ton of water out instantly. It's like using a fatter electrical cable. And that's exactly what we want on a spot welder, because we need to deliver that punch, instant punch, for a couple of milliseconds. If you use small cables, too high resistance, you don't get that punch of electricity that you need. I didn't know all this when I first tested it after doing these mods. At first I tried to power it from my jump start battery pack, but that was useless and barely made a mark in the metal strip. Next I tried my diesel SUV battery, which can supply 600 cold crank amps. Plenty enough, but again it was useless because although the battery is powerful, the internal resistance of the battery and the length of the jumper cable I was using was not giving enough instant current to the spot welder. So after doing some research on this subject, I decided to purchase a really decent lithium-ion battery with a 75 C rating, which means it can deliver a ton of current in a very short time. Plus the internal resistance of this kind of battery is very low. Another way I can explain it is like this. A big lead-acid battery with a high internal resistance is very powerful, like a fat sumo wrestler, but it is not quick enough to respond in a few milliseconds. In contrast, a comparatively small lithium-ion battery with a low internal resistance is like Bruce Lee and his lightning-fast 1-inch death punch, which is exactly what we need. In summary then, keep all cables between your battery and spot welder as short as possible. This will also reduce flyback, which will damage your welder. I believe the ones it comes with are 10 gauge, which is good. I shortened these because the battery already had some cable length. I used XT90 connectors because, again, that's what the battery already had on it, and they're suitable for the current required. Make sure to use a decent battery with a low internal resistance and a high C rating above 60 if you get a lithium ion. I have heard car batteries can work, but I have not done enough testing with these to recommend any specific types. I like the lithium ion because it's small and portable and useful for other things as well. Use good quality cable with low resistance, as some cheap varieties are not as good as others. Okay, I think I'll wrap it up there. Let me know in the comments if you appreciate this video or you have any questions. Hit the thumbs up button, share and subscribe to my channel for more content. If you think I've earned it, there's a link down below to buy me a coffee, which will help to keep this channel running and improving. Bye for now, we'll see you next time.